Good morning, ladies and gents. Welcome to Algorithms Episode 1. My name is Jeremy, and today's topic is maximum size subarray sum equals k. So, what does that entail? Well, today we're going to look at this very interesting problem. You have an array, right? You're given an array of numbers or integers in some other languages. And let's just say the array that we're given is -2, -1, 2, and 1. Now we're guaranteed that the sum of the whole array is not going to overflow an integer or however number is represented in your language. I'm going to be using JavaScript kind of concepts in these videos. And we're given a sum, k, to which some specific subarray portion of this array is supposed to add up to. So what are the qualities of subarray first? So subarray is basically a bunch of elements that are adjacent to each other. So you can't have, say, this element plus this element or something like that. You can't skip. So they have to be contiguous, but they can start wherever you want in the array and they can go as far and as wide as you can within the array. So in this particular setup, we can start to think about this in terms of, n-squared solution. And an n-squared solution is fairly simple. What we can do is we can say, okay, we'll start with this index 0. We'll sum all the elements here, and if we ever see that something sums up to k, we'll record it as a particular length, a particular number of elements, and then we'll do the same thing starting here, and starting here, and we can do certainly some optimizations, but in the end, it would still have to be, n elements, and for each n of the elements, it would be some proportion of n of elements on its right, and in the end we'll arrive to an n-squared solution. But there's a better solution. The better solution, you can actually do it in O of n time. How, you might ask? By making an observation, this observation here, that sum at current index I less sum at some previous index I, if that's equal to k, then we can say that all the elements between sum at the current index I and sum at some previous index I must equal to k, and then we can just subtract the current I less the previous I to get the length. So how do we actually do this? Well, you do it like this. First, actually, before we get too deep into this, in this particular example that's given, you can see that the sum of these two elements is 1, which is equal to k, and the sum of this one particular element by itself is 1. Its length is 1, but the length of these two elements is 2. Therefore, 2 would be the preferable answer here, just based on, the ask of the question. Now, what we can start doing is we can start kind of maintaining a history of sums, starting from the left to the right, applying this knowledge or like this intuition, and in the end, what we should be able to do is if we ever get to an I, where sum at I, at current I, minus k is equal to some other previously recorded sum within this history table, then we can get the length, and then we can compare that length to the maximum length and see whether or not it's bigger. If it is bigger, we'll update it, and in the end we'll return the maximum length. So let's start trying to do something like that. So we'll start off here at index 0, and we'll say, okay, actually we'll start at the beginning of the array, and initially sum is 0, and sum minus k is -1, although that is going to be true by default. And you can think about it this way. Let's just say you had like the full array from 0 to 3, actually added up to 1. What would the length be? The length from 0 to 3 is actually 4. And that's the reason why we initialize at -1. Because zero-based counting, if we had the whole array, or if we ever had to come back to the beginning, or even any time throughout this whole undertaking, we want the index to be based on zero-based index, but the outcome to be based on the regular one-based counting system. If that's not clear, I'm sure it's gonna take a moment to think about that, and I think it's gonna hit you very quickly, and you'll see as we iterate through this example, you'll see kind of how it works. So let's begin, and we'll say, okay, let's arrive at this index, so index 0. Our sum will become 0 plus -2, so that's -2. What's our sum minus k? So -2, well, first of all, is this -2 in this history? It's not, therefore we'll add it to the history, and we'll take down the index, which is 0. This is the sum, this is the index. Now let's check what sum minus k is. So this is going to be minus 2. So minus 2, minus 1, it's minus 3. Is minus 3 in history? It is not. Therefore, we can't do anything here. And we don't know what the maximum length of the subarray is. Initially, this max length, we can even write it here. Max length, we'll initialize it to 0. Because initially it's 0, and if we can't find anything that adds up to k, then we'll just return 0. Now let's keep going. Okay, so now we go to index 1. At index 1, what is my sum? So my sum is minus 2, minus 1. So that's minus 3. Minus 2, minus 1, minus 3. So my sum is minus 3. So let's record it here in our history. Minus 3. And my index is 1. And then let's check. Is sum minus k, which is, so this is going to be minus 3. And this is going to be minus 3, minus 1, so that's minus 4. Is that in my table? It is not. Therefore, again, I can't update my max length. It remains at 0. Okay, so let's move on. So now I'm here. So 2 minus 3, okay, plus 2 is equal to minus 1. So my sum is minus 1. Now, do I have minus 1 minus k inside of here? So minus 1 minus k, which is also 1. So minus 1 minus 1, that's minus 2. Is minus 2 here? It is. So what are we going to do? We're going to say that my I is 2. So that's my current I. My previous I, where I saw minus 2, is 0. So current I, 2, minus previous I, which is 0, is equal to 2. So update my max length to 2, and I keep going, right? Okay. So I'll also record minus 1, and that's equal to 2. And now I add 1, so minus 1 plus 1 is 0. Now I already have 0 in my history, and since this is the last element, I can actually close down the history right here, the history object. And since it doesn't add up to k, then I can ignore it. Now I've gone through my whole array, and I can say, hey, my maximum length here is 2. Therefore, I can return 2, and that's our final answer. Alright, welcome back, and now let's jump into the code. So this is kind of repetition of the question again. The two given examples, so this one and this one. And just as a quick refresher, what we're going to do is, our approach is pretty simple. We're going to go through each one of the indices here, and we're going to take down its sum, updating the sum variable, so on and so forth. So underneath here we can say we'll keep a sum variable, we'll keep a length variable, like max length subarray variable, and we'll keep a history object, right, which is going to take down all the histories. And what we're going to do is, at every index here, we're going to keep updating the sum. So as I mentioned in the video, if we have our sum variable here, initially it's going to be 0, then it's going to become 1, then it's going to become 0, then it's going to become 5, then it's going to become 3, and then it's going to become 6, like so. And then each time we're going to be checking whether or not, we'll have our history object, which will look something like this. Initially 0, 0, -1, but then we'll keep going and we'll say, okay, sum is now 1, 1 at index 0. 0 already exists, so we're not going to update it. 5 at index, what is it, 0, 1, 2 at 2, 3 at index 3, and then 6 at index 4. So that's going to be our history object, and we'll keep checking whether or not sum minus k is in history. So that's kind of my approach, and so let's see how that actually plays out in code. So initially what we're going to do is we're going to initialize some variables. So we'll say let max len sub r len is equal to 0. We'll also initialize our sum, which is initially going to be 0, and we'll also initialize the history, which is going to be an object, and inside this object we'll put in our defaults. And I spoke about this in the video a little bit about why this default is -1. Basically, if you ever had to look at the array and you had to take the whole full length of the array, would have added up to k. If we go 0, 1, 2, 3, 4, if we said 4 minus 0, they would not give us the right number of elements, because there's actually 5 elements in this array. So that's why we start off with 0 being -1 to account for that zero-based counting. This is kind of equivalent. The subtracting of -1 is sort of equivalent to adding 1 to an index, so you can think of it that way. But since we're using subtraction, we're going to do a -1 here. And each index inside of this history table is going to be off by 1 based on human counting. And of course, we start off at 0, 0 here is the sum, and -1 is the index. So we can think of first L is sum, second, or I guess not first L, we can think of key is the sum and val is the index. And then what we're going to do is we're going to say nums.forEach, which is a nice JavaScript array method. And out of it, we're going to take two things, number and its index. And we'll do a lambda function here, lambda expression. What we're going to say is sum plus equals num. So what am I doing here? Nothing more than just updating sum, just like I did up here. Going through each element, getting it, and adding it to the sum. Once I've added it to the sum, we're going to check history. We're going to say if not history dot has own property sum. So basically, if we haven't already put that sum, if that sum doesn't yet exist inside of the history object, then we're going to say history at sum is equal to I. Okay? Then we'll do another thing here. We'll say if history dot has own property sum minus k. So if we have sum minus k in here, which ironically we will, so 3 minus 3 is 0. 0 is -1. So -1 minus 3, or 3 minus -1 is 4. So the outcome here we predict would be 4. So let's go ahead and take a look, and we're going to say, okay, if that exists, then we'll say max length subarray is equal to math.max between max length subarray that we already have and I, current I, less history sum minus k. So history sum minus k, history at sum minus k will return an index, right? And that's an index where we've previously seen that sum, which means the sum between those two sums is k. And go back to the video and rewatch it if that doesn't quite make sense to you. And in the end, we'll just return max length, subarray length. So that's that. So let's see if this is going to work. All right. So now let's try to run it. And we have this subarray, and we have k is equal to 1. So let's go ahead and run that. And we'll get the answer 2, which is what we were expecting. And here we would expect the answer to be 4. So let's see if that's going to work. run the code, 4. So there you go, max length subarray sum, all events time. Thanks a lot for watching, and come back for additional algorithm videos. Thanks a lot.